Hello students, this is lesson U1A06d. Hopefully by the end of the period you should be able to say I can prove angle relationships between parallel lines and transversals. As this target is suggesting, we are going to be looking at geometric proofs involving parallel lines and transversals. So having that recognition, okay, let's write down all the tools that we have right now available to us, okay, involving angles formed by parallel lines cut by transversal, and that is we have these different sets. So we can either recognize as angles being congruent. So I'm going to write this here. Angles that are congruent versus the angles that are supplementary. So what are the angles that are congruent, okay, that are formed by parallel lines cut by transversal? So the first one that comes to my mind is corresponding angles. So all corresponding angles are indeed congruent. Another one that comes to my mind is alternate exterior angles. And another one that comes to my mind, if we think of alternate exterior, there certainly is alternate exterior. I'm sorry, alternate interior. All right. And then the angles that are supplementary, what are the types of angles that are supplementary then? Well, they are consecutive interior angles, and conversely, if we have consecutive interior angles are supplementary, we also have consecutive exterior. So these are the 5 types of angles, okay, that you need to have readily available at your grasp whenever the need to recognize them comes about. So let's take a look at some examples together. Please pause the video for a moment and draw this for yourself to see if there are any things here that you recognize as true, and then hopefully that will lead you to the final end of the proof. Let's take a look at this example now that you got a chance to draw all over this. Okay, we recognize that that AB is parallel to FE, so I want to put in these markings here. I want to mark them as in red. So these two lines are parallel. We also recognize that BC is parallel to DF, which I'm going to use another set of arrowheads to indicate that as such. Okay, so those lines are parallel. All right, so if that's the case, okay, we know from our understanding that this line here is actually the transversal for 2 pairs of parallel lines. Okay, so immediately, okay, having this understanding now, I know that angle ACB will be congruent to angle EDF. So again, ACB will in fact be congruent to angle EDF, because if I look at this in isolation, okay, so one more time, I look at this in isolation, the line that's in green and the line that's in pink, I recognize that that is actually alternate exterior angles, okay? So therefore, line number 2 must be true because alternate exterior angles are congruent. All right, recognizing that that is true, is there something else that we can draw? Let's take a look at angle. We're trying to show that angle BAC is congruent to angle FED. So let's see if that is actually the case. So what I'm going to do is I'm going to erase this so that I can see. so I can see for myself so that there are less distractions everywhere. Okay, so again, I have this line and this line are parallel. So now I'm trying to show that BAC, which is this arc over here, this angle over here, is congruent to FED. And if I isolate by drawing these two lines, okay, these are the two parallel lines that I'm focusing on, and this is the line that is the transversal that I am observing, then those two angles there, angle A and angle E, therefore must be congruent. And what's the reason for this, you may ask? Well, looking at this, okay, those two angles that we're claiming to be congruent, they're on the inside of the parallel lines. And are they on the same side of the transversal? No, they're on alternate sides. So these angles are congruent, again, because of alternate, and this time it's not exterior, it's alternate interior. So alternate interior angles are congruent. So these are, and that's pretty much it for this problem. Let's move on to the next one. Okay, so this one is slightly more abstract, slightly more involved. Please take a moment and draw the diagram as you see it, and then we're going to come back and figure out what to do with this. I'm going to zoom in here just because the image is slightly pixelated. My apologies for that. Let's take a look. All right, so I now have line 1 and line 2 are parallel, so I'm going to indicate that as such using these red arrowheads. And I know that L3 and L4 are cutting through those two lines, those two parallel lines. Now the objectives show that angle A, and I also know that angle A is congruent to angle J. So angle A, which is this guy over here, is congruent to angle J. Now the objective is to show that angle B is congruent to angle I. Angle B is congruent to angle I. All right, so upon inspection here, I know that A and B and I and J are what kind of angles? Just looking at this, what kind of angles is A and B together, that is, and what kind of angles is I and J together, that is, right? If you're thinking A and B are linear pairs and I and J are linear pairs, you're absolutely right. So angle A plus angle B must be supplementary. They must equal to 180. And line number 4, I want to say the same thing. Angle I plus angle J will also equal to 180. And how do I know that? Well, that's because linear pairs are supplementary. I'm going to write that over here. Linear pairs are supplementary. Linear pairs are supplementary. So, and it's the same reason for both of those statements. Linear pairs are in fact supplementary. All right, so let's take a look. Now, my goal is to show that B is congruent to I, right? B is congruent to I. But I also recognize that looking at this, right, I know that A is congruent to J, and A appears here and J appears there. And they happen to be supplements of congruent angles, right? Angle B and angle I are supplements of congruent angles. So what do I know? Well, my next step is actually the end of the proof for that first part. I know that angle I must be congruent to angle J. And the reason for this is supplements of congruent angles are in fact congruent. All right, so that's that part of the proof. I know that angle I and angle J are going to be congruent because of supplements of congruent angles are congruent. Now, my next objective, I'm sorry, I wrote the wrong thing. It's angle B and angle I. That's what happens when you're talking to yourself. Angle B is congruent to angle I. Okay? Because of supplements of congruent angles are congruent. All right, so number 6, okay, is I need to show that A is congruent to N. I need to show that A is congruent to N. Well, since I know A is congruent to J, but then wait a minute, isn't J congruent to N? Right? Let's observe this. Isn't J congruent to N because J and N are what kind of angles, you may ask? If you're thinking of corresponding, then you're absolutely right. So I know that angle J is congruent to angle N. And this is true because corresponding angles are congruent. I know that corresponding angles are congruent. Because corresponding angles are congruent, and because J is congruent to N, and I know that A is congruent to J, the next logical conclusion is that A must be congruent to N. Angle A must be congruent to angle N because I'm performing a substitution. Between which lines? Between line 2 and line 6. And here it is again in its entirety.